Good morning. Welcome to the session on design patterns in the light of Lambda expressions. My name is Venkat Subramaniam. We're going to talk about, we're used to design patterns programming in Java quite a bit, but I want to talk about how those things end up changing when it comes to using Lambda expressions. Best time to ask questions or make comments is when you have it, so please don't wait till the end. Any time is a great time for questions, comments, just about anything you want to ask, don't hesitate at all. Well, I first want to start out by saying I really hate design patterns. I know that was very motivating. Well, the reason simply is, if you really think about it, how do we really go about using patterns, and how do we really know what patterns to use? Well, we all can agree for one thing, right? Grandma makes the best pie, absolutely no doubt about it. And you've been raving about grandma's pie so long to all your friends, and your friends ask you, well, if it's such a great pie, why don't you make it for us? So you call grandma and say, Grandma, I've been telling about your pie to my friends. They now want me to make it. I want you to give me the recipe. And what does grandma say? Grandma says, oh, take some flour, take some sugar. He said, no. Tell me exactly how much flour. And then take some sugar. No, tell me exactly how much sugar. And the grandma says 2. You say teaspoon or tablespoon. And you write everything down. You go over it twice. And then you ask, what are the best practices? And then you go home that Saturday morning before your friends show up, and you bake that pie following the recipe, and what happened? It was a disaster. Last time I tried it, I couldn't get the spoon out of it anymore. And then you hide it and buy some a pie from the store, get over with it, and you meet grandma the next week and you say, this was terrible, you didn't give me the right recipes. And grandma says, why don't you just make the pie for you? And you go to the kitchen and you're having a good time with grandma when grandma's making pie. And what does grandma do? Grandma takes 2 spoons of sugar, measures it accurately, and makes sure it's exact measurement and puts it right? No. While she's having a good time talking to you, she takes some sugar and tosses it in. And you said, wait a minute, how much did you put? And grandma says, enough? And you're like, but all that recipe you gave me, what about it? Well, dear, you asked it. I didn't give it to you, right? Well, that's exactly the problem. The guys who wrote the design patterns book, the Gang of 4 book, those are the grandmas and grandpas of industry. And the worst thing they ever did in their life is write the damn book. And now everybody in the world thinks, I could do this. And then look what happens. So, in fact, the rumor has it, somebody wrote to one of the authors and said, dear author, I managed to use 23 out of the 24 patterns in your book. And for the life of me, I cannot figure out how to use that one last pattern in this program. Can you help? If you ever find this guy, kill him. You want to get him out of the gene pool, right? So nobody wants to wake up and... In fact, if you ever wake up one morning and you think, I'm going to go to work and use a pattern, that's a day to call in sick. Say, boss, I feel really terrible. I'm not going to show up to work. Well, having motivated you so much about design patterns, now let's talk about design patterns. I think the best way to apply design patterns is twofold. One is I find that design patterns are incredibly powerful communication tool. So when you're sitting down and talking with somebody and you're trying to explain the design that has evolved into place, it is extremely easy to say, that's the pattern I'm using here. So we don't go to work to apply patterns. We go to work to evolve the design. And then, of course, we can use patterns as a good communication tool. That's the way I feel about it. So, but then having said that, some of the patterns we end up using, I have this firm belief, the more design patterns we use is a reflection of the poor quality of the language. And in fact, a better a programming language is, we quietly use its features. We don't drum around and call about design patterns. So a lot of patterns I'm going to use here, we don't really call them patterns as much. We simply quietly use them. But it's a good communication tool oftentimes to use. So let's talk about one such pattern. But before we talk about it, let's talk about some of the influences of Lambda expressions. Now, one of the first things that Lambda expressions provide for us is that sheer ability to pass a function. So if you really think about a very good old API, thread.newThread, let's say for a minute, thread.start, for instance, and I'm going to simply say in main over here, and I'm going to run this code. Of course, it says in main, but within this thread, I'm going to say new runnable over here. And then within this, I'm going to say public void run. And then within the run, I'm going to say another thread over here, if you will. So if you look at this code right here, notice that when I run this code, in main printed first, and the other thread is running in a separate thread, as you can see. Now, of course, if you notice, this is a 21, 22-year-old API, but if I highlight this part right here, and new of an interface, I ask you, what is that called? Do you know what that is called? You call it anonymous inner class. I call it a missed opportunity. Because they should have actually implemented Lambda expressions way back in 1.1 rather than having anonymous inner classes. So that led us to a high amount of ceremony in code, right? So what we can do instead is, we can remove all that ceremony and we can simply pass a Lambda expression and get the work done. So wherever we were to pass a little anonymous inner class with a single abstract method interface, we can now send Lambda expressions very easily. So this becomes extremely powerful way to start communicating. And so we're not going to be introducing this hierarchy of classes when we can simply get done with a few functions, if you will. So I want to first start with the iterator pattern, if you will. So let's look at one example of an iterator pattern. Now, an iterator pattern is a very powerful pattern, probably one that we use quite often. It allows us to iterate through elements in a collection. But how do we normally use an iterator pattern in a language like Java? We typically use it using either a for loop or a for each loop, and then we simply say, while you have more elements, give me the next one, give me the next one. In fact, the for each statement in Java literally is a transformation to a use of an iterator under the hood. So if you take a for loop where you say for string, some name colon names, and then compile it and take a look at the bytecode, literally it is going to be, while there is more elements in the iterator, get me the next element. So we are using external iterators quite often. But thankfully, we can start using internal iterators moving forward. So let me give you an example here. Let's say we want to output, and I'll say factorial over here, and then factorial of, let's say, 5 for a minute. So to do this, I'm going to provide a little method here, which is going to be factorial. And I'm going to take a number as a parameter. And I'm going to say product over here is equal to 1. And then I say for int I equal to 1i less than or equal to number. And then, of course, in this case, we would iterate through. This is an external iterator that we are using. And then we would do something like product times equals, and then the index I. And then when we are done with it, we will return the product from this particular code. Now, that's pretty smelly iterative code, as we all know and we have done. It is imperative in style. We also use mutability in this code quite a bit. But we can deviate from this and start writing not only less code, but easier to maintain code and expressive code as well moving forward. So I'm going to go to a stream in this case, an int stream. And essentially, I'm going to go ahead and rewrite this code. And notice when I ran this, it produced 120 as a result. And I'm going to go ahead and replace this code that we have so far. And I'm going to simply say return in this case. And I'm going to say int stream.range closed. And the range closed simply says go from 1 to the given number all the way to the end of the number. And then I'm going to say reduce and start with the value of 1. And I'm going to take the product given to us and the index value. I'm going to return the product times the value I that I'm going to use over here. So we can see in this case, we have not only written a lot less code, the code is a lot more expressive as well, as you can see. So we are using an internal iterator in this case rather than using an external iterator. So when it comes to functional programming, we put iteration on autopilot. We don't focus on the mechanics of how do I navigate through the collection. We let the underlying library take care of the navigation, and then we are able to simply leverage and focus on what we want to do per element. Please. That's a good question. What's the performance? It is either the same or only better. And the reason I say this is because in good functional programming systems, and Java has adopted some of those styles, is they have an enormous amount of lazy evaluations. And as a result, either the performance is the same if you do the same amount of work, or it's actually less, better performance because less effort, because they optimally remove certain executions lazily. And so that's exactly what happens in this particular case. It can be better in performance. I talked a lot more about it in my streams talk yesterday about how you can leverage that, but that kind of comes in handy in this particular case. So that is one of the benefits. Go ahead, please.
Can we increase the
You want to increase the sound? Yes. So you're not able to hear me? Not at all. All right, then. Then how did you answer that question? Do you hear me now? This feels like some commercial, isn't it? Okay. All right. Let's hope that this doesn't lead into a static. All right. So the people in the next room are going to be very angry now. So, all right, I'll try. Is this better? Excellent. All right. So, all right. So given this, we looked at the iterator pattern, but I want to get to a different example here, what I would like to call as a lightweight strategy here. Now, typically when it comes to code, we use different patterns, and one of the patterns we all have used the strategy pattern. Well, let's come back to a different example here. Let's take a hypothetical situation here for a minute. Let's say we have a list of integer values. We'll call it numbers here, and I'll say arrays.asList, and in this case, I'm going to say these are the values I'm going to start with. So given these values, let's say I'm going to write a function called total values, and then in this case, I'm going to say numbers. So imagine you are working on a Friday evening. You're going to have this really, really exciting party, meeting a lot of your old friends. You're all excited and psyched about it for several weeks. And you're very eager to leave work, but there's a task on your hand. You got to write a function to total all these numbers. So you want to get it out really quickly and go to this party, right? So what are you going to do? You're going to say public, and in this case, static. Let's call it as int. We'll write it in imperative style for a minute. We'll come back and refactor it a little bit later. So I got numbers on my hand. And what do you do in this function? Oh, I'm going to say result equal to 0. And I'm going to return the result when I am done with this. And of course, we need to do the real work here. So what do I do within this function? I'm going to say int element is going to be from numbers, and then result plus equal to the number itself that you're going to total. So you got this work done, and you're about ready to pack up. You look at your watch, you're excited, but as fate may have it, your colleague comes back to you and says, I need one more function from you. I want to total not only the values, but I want to total all the even values also. And you look at your watch, it's getting really late. You say, you mean you want both the functions, one to total all the numbers and one to total even also? And your colleague says, yep, that's exactly what I want it now. Well, you're not really in a mood to write it, but you look around and there's a bit of a good news. The code to do the totaling is done, and you have almost everything you need. And you look at your watch and you tell yourselves, I mean, there's got to be a reason why they created copy and paste, right? I mean, if nobody should ever use it, why would they ever create it? In fact, it's such a wonderful feature. You got shortcut keys for crying out loud, right? So you could simply say total even values, for example, and you quickly say, if the value given to you is even, then do the totaling, not otherwise. So how cool that was, right? So you get that done. But unfortunately, as fate repeats itself, your colleague comes to you and says, I want one more function from you. I want to be able to total odd values. Now you know one thing for sure. Copying and pasting code a third time is an act of criminal negligence. But it's a Friday night and nobody is looking, right? So you make a change to it one more time and you say total odd values, and then you make a change to this one more time and you got it working. But as you leave for your wonderful party, guilt eventually kicks in because you know this is morally wrong. So you pull up near the closest Starbucks, you start refactoring the code, but as fate may have it, some of your other friends are hanging out over there. They come to ask you what you're doing, and before you could close your laptop, they take a look at your code and get to know your dark side, right? And they never want to return your phone calls. They don't reply to your text messages anymore. How life really turns really bad, right? So absolutely, let's pretend this never happened. So we are sitting there and writing the code, and we simply wrote the very first function. We have the total value sitting in front of us. That is all we have so far. And your colleague comes to you and says, I need one more favor from you. I need a function that totals even values. You say, you mean a function that in addition to that other one will also total even values? You say, yep, that's exactly what I want. Well, okay, I'm going to do that, but I'm going to do a little bit of refactoring before I do it. So I'm going to first go ahead and modify this function just a little bit, I'm going to introduce a second parameter here called a selector. So the selector is just an additional parameter. We haven't defined the type of this yet. We'll come back to that in just a minute. So we have a selector, and now I want to go in here and say, if the selector was really happy with the value we just provided, then I will go ahead and perform the totaling. Otherwise, I'll simply reject it. Now, of course, we want a selector. So the second parameter I'm going to send is not actually an object, but it's going to be a function. So given any element or value, we'll just say value, return a true. So notice in this case, the total values now takes two parameters, but the first parameter is an object like we did before, a collection of integers, but the second parameter actually is a function. Such functions are called higher order functions. So total values is actually an example of a higher order function because it not only can accept objects as parameters, it can also accept other functions as parameters. So we can send not only objects, we can also send functions as arguments as well. So this gives us an ability to pass a little function. But the question then is, what does this really function do? This function simply receives an input, and it really doesn't care what the input is. It simply approves the input, returns a true to say, I'm happy, go do whatever you want to do with it. So that's basically what this is doing. So what we can do then is come back here, and now we have to define what this selector is. Well, a selector is a new interface in Java 8 is called a predicate. Now, predicate has only one abstract method in it, and that method's name is called a test. So these interfaces which have only one abstract method, and you know several of those already, right? Runnable, callable, action listener, all of these interfaces have a single abstract method in them. Those interfaces are called functional interfaces. Every time I use the word functional interface, I just chuckle because every time I say it, I think about this. If there are some interfaces that are functional, what about the others? They are dysfunctional? Anyway, right? So you have these functional interfaces available to you now, and so now that you have the functional interface, anywhere a functional interface is expected, you can send a lambda expression as a parameter. So as a result, what I can do now is simply change the type of this to predicate, and then this is going to be an integer predicate. So this simply says you can either send me an anonymous inner class that implements predicate, or you can send me a lambda expression or potentially a method reference. So in this case, all we said is given a value, return a true. That's all we are saying in this case. So you can see that it performed the total and displayed the 21 as a result. Now we can go back and modify this, and we can then say, given a value, I want to check the value mod 2 is equal to 0, and I can return that particular value. So you can see how we were able to do that very easily. Now your colleague comes to you after a few minutes and asks you, I want another function that is going to return the total of odd values. You tell your colleague, go back to your desk and do it yourself, because I've written it in a reusable manner, so you can see that we can start leveraging that. We can even go to a next extent in this and simplify this even further. So for example, what we could do here is we could say, for instance, a public, let's say, static void, or Boolean rather, and I'm going to say is even, and I've got a number on my hand, and I'm going to return number mod 2 is equal to 0. So now notice, rather than writing such an amount of code, we can simply replace this with as simple as a sample is even and minimize the amount of code we have to write in this particular case. So it can reduce quite a bit of ceremony in the code, as you can see. So this gives an example of how we can actually pass around lambda expressions to the functions. So what did we actually do? We literally took this particular function, and the function is giving us most of what we really need. It performs the iteration for us. It performs the totaling of the value for us. And the only thing we removed from it is that little key decision making, and we extracted it out. Of course, if you're programming in the previous versions of Java, if you want to use this typically, you would call this the strategy pattern and hold a corporate design meeting before you could use it. In the case of Java, it's just the way life is, and you simply pass around lambda expressions and be done with it. So yes, you're using the strategy pattern, pattern. Like I said, we never really talk about it, we just use it. So it's a very natural way of evolving this code. But I promise that we will change the code and make it a lot more functional style. And notice the iterator pattern comes to picture one more time. And what we can do instead of using this pattern is we can replace this nicely here by simply saying return. And in this case, I'm going to start with numbers and ask for a stream. And then I'm going to specify in this case, given the stream, I want to filter, and the selector being a predicate can be directly passed to it. And then I'm going to simply say reduce and start with the value of 0 and use integer sum to perform the totaling. And so we can replace that with a functional style very easily. And you can see that we no longer are looping through. So here we are merging two different patterns together. The iterator pattern comes to picture, but we're also employing the strategy pattern to pass this particular object over here and the function along with it. Any questions, comments before we move on? All right, so sounds good. So we looked at this particular pattern, how we could use it. Now I want to go to the next pattern here, which is about delegating certain functions. Now let's talk about this for a second. How do you go about delegating functions? So let's say for a minute I'm interested in getting a stock price and doing some work with it. Now typically what we do is we deal with not only writing code to do the real work, but we often want to write code to do testing as well. And when you start writing code with testing, what do you normally do? So let's think about the scenario just for a minute and look at the burden and the heavy weight we normally deal with. So let's say we have a class called stock calculator, let's say. So my class is called stock calculator, and the stock calculator has a method. Let's call this as compute. So I have a compute method, and this takes a string ticker, and it's got also an int, let's say stocks. And what I want to do here is return stocks times and then get price for the ticker. Now obviously the question is, where am I going to get the real stock price from? So if you're unit testing this code and designing this code, what do you normally do to implement this and also be able to test it? Well, one of the first burden you would get into is you would first start defining an interface called stock price, let's say a fetcher interface, right? So you would create a stock price fetcher interface, and that would have a method called get price on it, which will take a ticker symbol as a parameter, and then of course that's an interface. And then what would you do? You would then start injecting that into this as stock price fetcher, and then you would call this as price fetcher, and then you would provide probably a public void set stock price fetcher, and then you would then say, let's call it stock fetcher, and then you would provide the stock price fetcher as the parameter here, and then you would start assigning that to the particular parameter. And then what would you do? Then you would go start writing a unit test, and what would you do in your unit test? You would implement that stock price fetcher in your unit test where you return mock values from it, and then the integration code, you would first have to go implement a class that implements the stock price fetcher interface. With me so far? Well, and you find out that that stock price fetcher was written by a third party and not you. Either now you have to bribe them to change their class to implement your interface, which is unlikely, or then you have to write an adapter pattern, and then your interface will be implemented with your adapter, and your adapter will then talk to the third party class. Making sense? And what is the net result of this? A lot of bloated code, isn't it? And so this is what we've been used to, writing a boatload of code. Of course, we have another alternative. That's why we don't do unit testing, right? So we don't have to write all that code. So the point is we don't have to be enduring so much complexity. What do we do, and why are we doing all of that? Only to say, I got two implementations, I want to switch between the implementations at will. So let's try this example very differently. The very first thing I'm going to do is I'm going to get rid of that interface first of all. And I'm going to come back here and I'm going to introduce a thing called a function right now. So we brought in a function, and I'm going to change this to a function, and I'm going to say string a comma double, and I'm going to call it as stock price fetcher. So notice the very similar thing as to what we did before, that's what I'm using. However, now the stock price fetcher, very similar to what we did, but I got rid of the interface so far. So we got the stock price fetcher that we created here, and then I'm going to provide a way to set that particular object. So this is going to become a function which takes a string and a double, and we'll call this as a fetcher as well. But in this case, what I'm going to do is simply set that fetcher to this particular object reference here. So we got the reference on our hand. So now I'm going to simply go back to this code and say the price fetcher dot accept, and I'm going to send this ticker price to it, and then it's going to return a double value, and I'm going to multiply with the stock price. Now the question is, how would I actually go about using this particular code? Well, in order to use this code, all I'm going to do is assume that this is in unit test. Let's just assume that I'm in a unit test where I would do asserts and all those good stuff, right? So what would I do in this case? I'm going to simply, in this case, create a calculator. So I have a calculator, and in this case, I'm going to say new stock calculator. And all I'm going to do is simply say calculator.set, what is this called? Set stock fetcher. But notice what I'm going to give to this particular object. I'm going to say symbol, and given a symbol, return a value of, let's say, 30. So in other words, I completely marked out, very lightweight marking, isn't it? So rather than creating a class and an interface and inheritance, we got rid of all of that and said, all you'd want is that one function. So here is a mock implementation of that function for you. So given the stock price, I'm going to give you that price value. So then I'm going to output at this point simply calculator1 dot compute, and I'm going to give some symbol here, let's say ORCL, and then I'm going to specify, let's say, a value of 3. So what does this code actually do at this point? So all we are telling this particular code is that given this particular value, type checking kicks in here. So given this particular value, we want to really get the result of it. Let's go fix some of these errors at this point. So on line number 9, it tells me there's the fetcher. I called it fetcher now. So let's make sure we got all the errors out. And this is going to be actually an apply method, which is a method on the function interface. And now you can see that I got a value of 90. So the beauty of this is, if you want to mark out some implementation, you didn't have to go through an interface hierarchy. You can simply delegate your code to a function very easily by using a function interface. Now, how do you talk to the real object at this point? Well, let's go ahead and see how we would go into a real code or integration code. How would that look? Now, remember I mentioned that integration. So remember I mentioned that a third-party code may be there already, and you don't have the power of changing a third-party code. And what do you normally do in a unit testing scenario to get around it? You implement that adapter pattern I talked about. Your adapter will inherit your interface and route the calls to the third-party class, which is a burden of an interface you have to create, a burden of the adapter you have to create. All that bulkiness simply goes away from your hands. So notice what you can do now. I'm going to simply say stock calculator, and let's call it as calculator 2 equals, in this case, new stock calculator. Or actually, we can reset the calculator on the other one. Actually, let's do that. So we could simply say calculator1 dot set stock fetcher. And given a symbol, what do I want to do? Well, I've got a little class here called yahoofinance.java, which actually gets a price and returns my value for me. So I'm going to simply say over here, the class that I want to use, which is called Yahoo Finance. Let me just copy that. Oops, not that one. So let's go ahead and bring the real class. So let's bring in the class Yahoo Finance here. So I'm going to simply say, given the Yahoo Finance, I want to get the original stock price. So let me get that function from here. So notice I just replaced that with exactly that one single call, and let me make sure I'm connected to the internet right now. Seems like it. So if I go back and run this code now, so I'm going to say output, and I'm going to say what is this called? Calculator1 dot compute, and let's say ORCL again, assuming that's a correct stock symbol, and give a value of 3 one more time, and let's see what this is going to do now. So in this particular case, Yahoo Finance, bad return type lambda expression. So let's make sure that I'm getting the right value here. So symbol is going to be the symbol that I'm going to pass. Let me make sure I've got the right values here. That's a string it's taking, and a double value it's going to return. So that should have actually worked. Let me see why that was not happy with it. So let me actually see if I can use this get price. So it should should be the same. So Yahoo Finance is the class, and the get price is the value that I want to return, or the result of that. And that was returning a double value, so this should be returning a double value as well. So let's see what that's saying. Bad return type for Lambda, double is not a functional interface, so I'm not exactly sure. Let me do the extra work here just to get around it. So I'm going to say Yahoo Finance dot, and then get price, and then I'm going to give the symbol to it, right? So we are receiving the symbol in the set stock fetcher, and then once we get the symbol, we are returning the symbol's price at this point and asking it to use it. I'm not really, oh, you know what? I think I may know the problem. It probably is returning some other type, but it is not. It's returning a double. So I'm not sure exactly what the error there is. I got to go back and look at it. But the point really is you could use the real exact solution here, and you can replace it. So as an example, here's another mock for us. So we can simply say, here's a different price I want to send. And this could be a real code you can implement at this point. So I got to debug that and see what it was causing as a problem. So essentially the idea is you can, instead of using interfaces, you can simply go back and start using functions. And so function is a very lightweight functional interface. And so rather than really depending on a hierarchy of interfaces and classes, you can start using Lambda expressions to pass around. And this is basically a simple example of delegation that you're looking at. So in other words, the stock calculator is delegating part of its responsibility to the price fetcher. And in a typical design, rather than having a hierarchy of classes, we could easily do this. You could argue this is also yet another example of the strategy pattern, because strategy is often used for delegation as well. So that's what basically it comes to. So we looked at a couple of different examples. Any questions, comments before we move on from this one? All right, so let's go to one other example here. I want to talk about decorator pattern. So if I say decorator pattern as a Java programmer, what example comes to your mind? What was that? Yeah, but example, what example readily comes to your mind? Java I/O, that's correct, right? So the example that comes to your mind is probably this example. Tell me if this is true. You probably are thinking, if somebody says decorator pattern, you're thinking something like a buffered reader, and then a buffered reader, so buffered reader, and then equals new buffered reader, and then within that you probably have new, data reader, I don't know, data input stream reader, and then within that new file input stream reader, and maybe the file name after that here. Does it ring bells? And after looking at this code, would you ever use decorator pattern? Not really, right? Because it scared the daylights out of you. It's like, come on, I can't be using this. This is crazy. You're doing this hierarchy of class after class after class, and that's such a mess. And nobody really cares to use this, except that it's in the library, and we say, yeah, we could. In fact, it doesn't end here. After you write this code, you got to put another 30 lines of catch blocks around it as well, right? And it only gets more painful. So we all said, decorator is kind of nice, but no, I'm not going to use it. But what if decorator is really nice and simple to use? But before I talk about that, I want to show you one other example, because we're going to use this one. So I'm going to create a function, integer to integer. I'm going to call it inc equals. Given a value, I want to return a value plus 1. Now I can simply say inc over here. So output inc dot apply, and I'm going to send a value of 4, and you can see that it added the value to give us a 5. Now I'm going to also implement, let's call it as dbl, and this is going to take a value and double it. So now you can see I can take this value and I can now say in this particular example, so I can say a double dot apply, and we know what the result of the previous call was. It was a 5, so I send a 5 and it doubles the value to a 10. But typically what would you do? You would probably do something along these lines, right? Integer temp. temp is the worst word we could ever use, right? Those are called garbage variables. And at night, temp really goes home and cries, right? It's like, why me, right? When there are other beautiful named variables. So that's what we normally do. So inc.apply, and then we pass a 4, and then what do we do? Output dbl.apply, and then comes the temp again, right? So now we would write something like this. But what we really want is a combination of those two. So how about doing this? Output, and I'm going to say increment, and then perform the double and apply the value 4 on it. Remember, the result was 10, and that's exactly what we have on our hand. So in other words, you can do function combination very nicely. So you can take discrete functions and you can nicely combine and chain them together, and now you got one big function that actually, well, big not as in size, but one function which actually chains through and implements all those functions. So in other words, kind of like think about this as two people standing next to each other. Each person has a function, but they kind of point to the next person like a linked list. You pass the data to the first one, they do the work, and automatically pass the result to the next one, and they do the work, and then what comes out on the other side is a cumulative effect of these operations, right? So that's basically what you have on your hand, is that nice transition in through this, and you get the result of it. So this gives us a way to use the and then and nicely perform the computations. Do raise a voice a little bit because sometimes you're in a blind spot, so I don't mean to ignore you at all, please.
So in this case, how would you go about incrementing it conditionally? So let's say you want to have increment, but conditionally then double it.
Yes, so in those cases you would probably throw in a filter in a stream, and the filter would then say, if this condition is true, then continue further. So much like how you can combine functions together, you can combine predicates together as well. And if you really think about it, a predicate is a special form of a function, right? Because a function takes one input and gives one arbitrary output. A predicate also takes one input, but it always gives you a Boolean output. So you can kind of start combining them together with filter operations, and you can put them together. So that's basically what you're seeing in this case. Now, given all of this, let's take a look at a slightly different example. This is going to be a little bit more work, but let's see how we're going to implement this. So I'm going to implement a class called camera, and my camera has a function called a color snap, and it's going to take a color input as a parameter. So my camera is going to take a snap, and it's going to just take some input and produce a snap of it. Well, I'm going to simply say in this case, return processed. And what is this processed? So color processed equals, so processed equals input. And you could do, do work here, right? So we'll just skip that part. And so you can have that returned to you. Now I want to use this, so how would I use it? So I'm going to say camera, and I'm going to create a camera object. Well, actually, let's do this. Let's say print, snap, and this is going to take a camera, so new camera, and that's all I'm going to pass for now. So how would I go about using this? So the first thing I'm going to do in this case is my function, which is going to be print snap, is going to take a camera as a parameter. So this is going to be camera. And in this, all I'm going to do is output camera.snap, and I'm going to simply send to this one new color, let's say 125, 125, and 125, 3 colors. So not a whole lot, right? So let's go ahead and try what happens so far. So art and then color, so I brought that in. And so all I have done so far is simply write that. So you can see the garbage in, garbage out, it gave the same result as the output. Not a big deal, right? But of course, I want to do some nice filtering and processing of my stuff in my camera. How would I go about actually doing that? So notice what I'm going to do in this case. I'm going to say function, and this function takes a color as an input and gives a color as an output, and I'm going to say filter over here. Now, to begin with, I don't want any filter. I want just a dummy filter. So I'm going to create a function here called set filters, and I'm going to say function. This is going to be a color, comma, color, but I'm going to use a var args in our hands. So that's going to be a var arg, right? And I'm going to call it as the filters. And what am I going to do with these filters? Well, for now, I'm going to simply say filter equals, and simply put, I'm going to simply say, well, given a color, just give me back a color, right? I'm not even using the filters given to me at this point. So this is a var arg sending a filters. It simply says garbage in, garbage out. And one more function before we are done with this. So public, let's say camera, and it simply calls set filters with absolutely nothing. So in a sense, I don't have any filters yet. And the only filter I really have is garbage in, garbage out. Takes a color and gives back a color. That's all it is, right? So let's make sure we're building up this code properly, and then the output should still be exactly the same as the output we saw earlier, where we are just getting the value and returning it. Well, it's giving us certain warnings over here, but as Java programmers, we definitely know exactly how to deal with these warnings. So suppress warnings, right? Suppress warnings, and then say unchecked, and then smile at the compiler and say, now what? Okay, so so now you're basically suppressing that warning, and so what are we doing? Oh, error, suppress warnings. Okay, all right, you win compiler this time. All right, so that's basically the warning that we have suppressed over there, and now you can see the garbage in, garbage out. Well, but what do I really want to do? I want to be able to send different kind of filters to this, obviously, right? So notice what I'm going to do now. I'm going to now say, I'm going to call a print snap this time, but to this print snap, I'm going to go ahead and call the method called the set filters. And I'm going to do just a little bit of a trick here, just to save our efforts a little bit here. I'm going to violate that beautiful tenet of getters and setters, and I'm going to make this a void method into a camera and simply say return this over here. So now what am I doing? I'm going to go back to this camera and say dot set filters. But what is a filter after all? A filter is just a function, isn't it? So in a way I can say, given a color, do something with the color. Make sense? So I could say, given a color, do color dot brighter, right? So brighter, B-R-I-G-H-T-E-R, right? I could write it. Or I can say, I don't need to work so hard, so I'm going to say color colon colon brighter. So we are simply saying, make the color brighter. Now, of course, we haven't used this filter yet, so we need to use the filter. So what am I going to do? Now, remember, I don't have any filter in the beginning, but I want to really put together a filter and do some work with it. So I'm going to perform one nice operation here. I'm going to first of all say the filters. So here's a quick quiz for you. This var args, what is the real type of that object? An array, thank you. Now, if you have a list, you can call .stream on it and get a stream from it very easily. But unfortunately, this is not a list, it's an array. So what I'm going to do instead is, I'm going to simply go back and bring in the util.stream.stream, and now I can simply say, in this case, nicely, I'm going to simply say the stream.of the filters. So that gives me a stream from an array, and then I'm going to call the method called reduce, and you saw me use this earlier, right? Reduce takes a collection and brings it out to a single value. And the reduce basically says, in this case, I'm going to take all these values, and I'm going to say function, and then that function I used a few minutes ago. So what are we now doing? We took each of these little functions and said, hey, you all get together and form a chain, right? That's what you're saying. So you take the collection of these functions and saying, form this chain of these functions using the and then function. Now, when you are done with it, you are going to get a collection all together, and then you say, well, now that I have a collection on my hand, what am I going to do? Well, it's possible that you don't have any function in the filter at all to begin with, so you can say, or else, just give me this dummy function of a color to color, right? So essentially what we are doing here is, we are changing the filter to be a nice chain of all these functions together. So this one call simply says, if you give me two functions with you, and I'm going to immediately put them together like that, right? So it says you call this filter, it does its work, passes to the next filter, it does its work, and then returns a result to you. And so you take discrete filters and you put them together in that chain. That's basically what you have done in this particular case. So given this, assuming I wrote it correctly, let's go ahead and try this out and see what this code wants to tell us. And this time around, well, okay. It's another warning, but we have mastered this technique already, so we don't have a problem dealing with now. So let's go squash that. So right there. Anything else? Okay, so we can run this code one more time, and what do we see in this particular case? Well, in this particular case, of course, I need to apply the filter, which I haven't done. So let's go back to this and say, what should I say in this case? Filter.accept, or rather apply the input. Am I making sense? Because you want to eventually use the filter after all. So now if you notice, the color that came in is exactly the same in the first one, but you see it much more brighter in the second one? Yeah, so we have brightened it a little bit. Well, let's try one more example in this case. Now, in the second case, what I'm going to do is simply call this, and I'm going to say a darker, and now we can run this code and see what this is going to do, and you can see in this case, it's a lot darker than it was. Now comes the interesting part of decoration. Not sure exactly why we would do this, but I can say brighter, comma, color dot darker, right? So you make it brighter and make it darker. Now, of course, when you do such things like that, what's going to happen? Well, I'm going to give you two values here, the colors brighter and colors darker. So that is one, this one is the brighter one, this is the darker one, colon, let's change that. So when we do this, let's see what happens. And of course, what you see here in the third example is that it came back as 124 because physics says don't mess with it too much, right? There's a bit of loss of, a thing here, so you got a little loss in that. But you can kind of get the picture, right? So you can see how we did decoration, but let's think about this. Would you do this decoration if it was so easy to write and less noisy compared to all that new file input stream, new buffered reader, new? Whereas this one is simply just taking the functions and putting them together and saying, decorate them through, right? So that is one of the things you see is it becomes very lightweight to start decorating with multiple functions as well. Life becomes a lot easier. So again, we can see how the lambda expressions begin to shine, but of course we are using a little bit more than lambdas here. We are benefiting from the way that function composition works, and that is another feature in functional programming, is that we can compose functions together to make them associative. So that is exactly what we just did in this particular example. All right, so let's switch over to the next one, creating a Fluent interface. So I've got two more examples here, so let's get through these two examples. The next one I want to do is start with the code we all are familiar with and probably have written a million times over. So let's talk about one other function I want to use here. So let's say we have a class called mailer. Now the class mailer has a few functions. A public void, let's say this is going to be called from, that takes a string, and I'm going to say, address. And what should I do within this? I'm going to say, in this case, print line, let's call it print, and I'm going to simply print the from. That's all I'm going to print. So what is print? I'm going to say public static void, let's say print, and just to save myself some effort here, so output str. So that's my from method I've written over here. That's all I have so far. Well, now that I have my from method, the next step here is to write a few more methods I would actually need from this. So give me a second to write those. Remove the wrong parts. So let's go ahead and bring that one again. So let's remove this. All right. So now that we have a from method, what's my next step? Well, I want to have a few more methods. Let's shorten this a little bit. There we go. So it's easier to see. So there's the from, and I got a to, and I've got one more which is called subject, and I have a message, and one more which is send. So what does the to do? To says to, subject says sub, and this is going to be some line of the subject. Message takes a body, it simply says message, and I don't want to really do any real work in those methods, and send eventually simply says sending. So we are all set to use this particular interface that we have on our hand. So coming back to this code, of course, Java says it wants semicolons. So let's go ahead and provide the semicolons. The other day I was programming in Java, and it's, I kind of switched between languages, and most languages I use these days don't require semicolon. And the compiler said, you're missing a semicolon. And I found myself arguing with the compiler. I'm not really missing, you see. So anyway, so we have this particular code ready. Let's go ahead and use this code. How would we go about using this? So I'm going to say mailer equals new mailer, and mailer dot from. Well, where is this going to be from? Mailer dot to, where is this going to go to? Well, this is going to go to my address. Great. And who is sending me the email? Well, who else? builder@agiledeveloper.com. Great. And it's got an important mail to send me, so subject. And this is the email I get very often from my builder. It normally says, your code sucks. And mailer.message, and my beautiful builder doesn't stop at that. It tells me how it sucks. And then finally, mailer.send. So when I run this code, you can see that seemed to work. We just worked on the interface. Has anybody written code like this before? What is that called? Java programming, right? So we all have done that, right? Now, what is wrong with this code? It's got two problems. One is, I love that. You are the brightest man I know. You should see this. He's actually laying down. He figured the right technique. So the point really is that you are, if you don't mind, I have to take a photo of this. So essentially the idea really is, so if you don't mind. All right, well, so essentially the idea really is that you have really taken this particular interface and you have called several methods on it. So it's extremely noisy, if you noticed. That's one problem, right? If you were to do this in real life and you kept saying, Joe, Joe, Joe to the person next to you, Joe will probably eventually strangle you, right? That's really noisy. The second problem in this case is when you really come to the line number 23, should I reuse the mailer or should I not reuse the mailer? What's the right answer for it? The usual answer you get is that answer you all hate to hear, go read the documentation. Now, when you read the documentation, what does the documentation tell you? Usually nothing, but it's usually more than nothing. The other day I was looking at a documentation. Honestly, I did not know what this means. The method name was called pass-through. And I was like, what does this mean? So I went to the documentation, and the documentation immediately helped me. It said this method allows you to pass through, right? So these are called insult the programmer, right? So now you're scratching your head, and you download the source code if you can. Now you're reading the source code. That only makes it even worse because now you're complaining about the code you're reading. So you're not solving the problem, you're getting sucked into this. Well, if this can be very obvious, wouldn't this be nice? And so the problem is this. If you should not reuse this object, and if you do, you got a bug. If you should reuse this object and you don't, you have inefficiency. So how do you really deal with it? So to fix this problem, what I'm going to do is solve this with a little bit of a little difference here. So the first thing I'm going to do is I'm going to first go to the send method and fix a few things. Well, the very first thing I'm going to do here is notice all these methods were returning a void. And I'm going to change that very quickly, a little single step at a time. I'm going to change all of that to return a mailer. So now each of that method is returning a mailer object. Now obviously because they're all returning mailer object, I don't really need to do that for the send method. But because each of these methods are returning a mailer object, now I need to go to the very end of these methods and say return this on this method. So every single method is now returning a this current object. The code is still working. Well, we made a little bit of a change. Now what I want to do is I want to go back to this method and I say static void send. So notice that send is no longer an instance method, it became a static method. So now I go back and say I want to change this body to consumer, and I'm going to say mailer, and I'll say block. And now I'm going to go ahead and create a mailer by myself here. So mailer equals new mailer. And then I'm going to call this block and ask it to accept this mailer I just created. And when it comes back, I'll do the error checking and perform the sending operation. Now as a result, notice what the code is going to change to. The code now says simply call mailer.send, and this gives us a mailer object as a value to our little lambda expression. And now I'm going to take this code from here, all except the send method, and I'm going to put it down here. And now you can see we just got the mailer. And I'm going to simply say, given each of these mailers, I'm going to start with the very first mailer and then call the methods on it repeatedly. So notice I don't need to repeat the word mailer, mailer, mailer. We're using a function composition, and I can get rid of all these semicolons in the very end. So now what we are ending ended up with is simply this code that's going to perform this operation for us. So you can see how we rewrote this interface in a nice way to make it very fluent. And so if you look at this code, it does a couple of interesting things. The very first thing is we eliminate the noise in the code. We're not repeatedly saying mailer, mailer, mailer. We used what is called a cascade method pattern. Now, some people call this the cascade method pattern. Other people call it a train wreck pattern. It's up to you what you want to call it, but essentially it nicely cascades through and gives you that composition you can see in this case. And the second thing you are doing in this particular case is you have come to line number 26. Now the question is, on line number 27, can I reuse the mailer? And the short answer for that is, what mailer are you talking about, right? Because we don't have a mailer object on our hand. It is in the context of this lambda. It's given to us, and when we return, it disappears. So we don't have that concern of reusing it. If it should not be reused, good news, you wouldn't be reusing it. If it should be reused, then the author of the mailer can take care of that internally. It's no longer your concern. So that's the beauty of this, gives you the fluency in this particular code very nicely, as you can see in this example. So that's what we saw so far in terms of using the fluency and creating this. Questions so far? Good, still good? Oh, please.
So one question on chaining methods.
Yes.
Isn't there an issue with when you're chaining methods from one to another, if there's any sort of change that goes on in there, control error of some sort?
That's a really good question. So the question is, when you're performing through this chain, how do you deal with errors and exceptions and stuff like that? Unfortunately, though, so there are two issues. When it comes to true functional programming, exception handling derails the execution path. Now, in true functional programming, I'm not talking about Java right now, in true functional programming, you don't want any bearing on the order of execution. They call this referential transparency. Now, the question then is, how do true functional programming languages deal with that problem? The guys who wrote true functional programming languages are extremely smart. They said everything is impure, we have full referential transparency, and we have monads, because they know that nobody understands what monads are, right? So that's a really nice trick they used. So in other words, monads really are to introduce an order and impurity in a world where there is no order and impurity otherwise. So that is essentially what the concept is. But Java is not a pure functional language by any stretch of imagination. In fact, it's quite the opposite. It's an imperative language for most part, and we have bolted on functional style on it. So Java doesn't handle that. That's the first problem. The second problem is, in the case of Java, we have the stickiness of checked exceptions versus unchecked exception. It is not a concern at the JVM level. Bytecode doesn't care about checked versus unchecked, but the Java compiler does. So as a result, if any of these functions you saw were throwing a checked exception, and if you're going through the stream library for composition, those would not compile and you would get errors. In this particular case, you don't have the problem because you are directly calling your own functions, and as a result, this is as good as calling these functions individually. So the answer differs based on whether you're in a stream composition or your own composition. So that's why I want to distinguish between the two. In a stream composition, life is a lot more difficult dealing with exceptions. In here, it's a lot easier because every one of them is as good as separately calling with a temp variable, and you pretty much can wrap this into a try-catch block around it, and you can then go to the next extent to say, rather than using consumer, remember these are single abstract method interfaces, you can create your own interface which has one abstract method, but that method could receive a throws exception. So this can be propagated all the way to the caller as well. And so you can start handling the exception through that. So, but you got to be careful. The answer is a bit different between your composition versus stream composition. But in an example like this, it's not that hard to do at all. But you cannot use consumer because consumer is in denial that you would ever throw an exception. But you can create your own exception with the throws clause on it. Sorry, you can create your own functional interface with the method with the throws clause on it, and then you can participate in the chain of function being thrown, and you can do that. Yeah. So really good question. So let's now talk about one other thing, and the pattern I'm going to show you here is very much like what you just saw, but the intent is quite different. But before I talk about this pattern, I want to give you 3 solutions to this particular problem. And hopefully the final solution is what you would end up liking. So let's talk about this with a slightly different example. Well, let's say for a minute we have a class called a resource. So a class called resource, and my resource class is going to contain a bunch of interesting methods for us to use. The first method is a method called op1, and all that the op1 says is op1. I also have a method called op2, and op2 simply says op2. And I also have a constructor for this. We'll call it resource. And all I'm going to do in this constructor is simply say creating. And finally, I'm going to write a method called finalize. And in the finalize method, I'm going to simply say cleanup. So we got all these different methods available for us. Let's go ahead and use them. So I'm going to say resource equals new resource. I created a resource object. Then I say resource.op1, and I say resource.op2. So now when I run this code, you can see it created the resource, ran op1, ran op2, but it did not do the cleanup. So my first question is, oh my gosh, did I really mistype the word? Did I misspell finalize? Looks like I actually typed finalize properly. So why didn't it clean up the object when we are done with it? No guarantees, right? Because a garbage collection in Java is like the garbage collection in my neighborhood, right? They're like, you know what, it's not important, right? We'll just not worry about it. So as a result, the garbage collector never kicked in. So this reminds me of a project I was involved in. A client called me and said, could you come in and help us review our code and do some mentoring? But along the way, maybe you can help us fix a problem we've been having for a few months. And I asked the manager, what problem do you have? And the manager simply said, go ask the programmers. So I went and asked each of the programmers. But one programmer nailed it. And the programmer said, our application works fine most of the time. I said, well, that's good. Can you tell me what time it doesn't work? He said, of course, I know. It doesn't work between 7:15 and 9 in the morning. I said, oh my gosh, really? Every day? He said, no, only Monday through Friday, right? And Saturday, Sunday, it works fine. So I was completely baffled. I mean, how could it not work Monday through Friday but work Saturday and Sunday? How could it work at other time but not 7 to 9? Well, it turned out this is a company with 100,000 people, and they had, what they were developing was a portal application. So you know what's happening between 7:15 and 9 in the morning. People come to work, they log in, and they get to use your portal whether they care or not. So as a result, there was a very high demand than usual during that period of time. As I was doing code reviews for them, I eventually came across a class, much like this resource class, and guess what this class was doing? In the constructor, they were making a call to a database. They open a connection. And in the finalize method, they were closing the connection. And of course, because they had a lot of memory, the finalizer did not care to run, and they were backing up all these connections, but the exception was not being propagated properly. So I had a hunch, and then one of the engineers was sitting there and looking at the connections in the database, and I went to them and said, hey guys, we could try something if you don't mind. And the change I made was I said, let's change the finalize to close, and then I came back and said resource.close. And now I asked them to run the application and monitor, and they immediately reported the problem was gone because the database connections, which was loading up, now all of a sudden was at a very, very low level. And so that was the first solution I proposed to them. It was really interesting to watch what was going on in the team. After lunch, the boss comes back from lunch and says, how's it going? And the team was eager to announce that the problem they've been having for several months is fixed. And they said, well, we got the problem fixed, and Venkat showed us what we can do. And he was, as he should be, very curious. He said, what did you guys do? And the team said, well, Venkat asked us to write this one line of code. And he said, okay, that's great. What else did he do? And it's like, no, that's it. We added this one line of code, and the problem is gone. And there was a little pause, and after that I heard him say, well, if you only wrote one line of code, do we still need to pay him, right? So, yeah, okay. So the point really is that if you really look at this code, now there is, of course, a problem in this code. Do you know what the problem could be? The problem that this clause may not get called. Exception, that's correct. So we have to handle that too. So what am I going to do? I'm going to say try. And then within this, I'm going to go ahead and move this to the try block. And I'm going to say finally. And then within the finally block, I'm going to call the close operation. Now, notice that it is working the way it's supposed to. But there are two problems with this code. The first problem is, you have to remember to put the try and finally every single time. If you don't put try and finally, what happens? The cleanup doesn't happen, you're back to square one, and then you can go around blaming programmers. If you only know how to code, this wouldn't be a problem. I don't like blaming programmers because I feel like we're all brothers and sisters for that, right? We don't blame each other. Well, the other problem really is that this is noisy, and it just stinks when you look at it. And you don't want to be writing that much code. You want this to be a lot less code to write and more fluent and more concise. Let's solve the second problem first. Not the forgetting problem, but the problem of conciseness. Well, there is some good news. In Java 7, there is a feature called ARM, which stands for Automatic Resource Management. And what Automatic Resource Management does is, it says you don't have to write this high ceremony code. So what it suggests is that you come back to the class and say implements, and I'm going to say auto closable. And then once you implement auto closable, you can get rid of the finally block. So no longer do you have to say that finally block. What a relief, isn't it? And then you simply take this resource from here and you embed that within the try block like this. So this is sweet, I can agree with that, because it got rid of that ceremony high noise code. And so it's the ARM says, as long as the class is auto closable, you can simply say try, and they call it try with resource, and you can say try and then do your operation. When you leave line number 18, it performs the close for you automatically on line number 18. So you can see that in this case, the cleanup happened automatically. Now, this is definitely very attractive because it is less noisy. I'm all for less noise and more fluent code. But unfortunately, though, what will happen if I don't put the try block at all and I just simply write the code the way I used to write the code before? I did not put the try and I did not put the finally one more time. What do you think is going to happen? Will it catch? Will it complain? Well, let's run and see. When I run this code, notice it didn't do any help at all. But don't act surprised. You know the answer, this answer already. Because you know very well you should never trust a feature with the word management in its name. So the point is that it doesn't work. So what if we can actually make it work and there's only one way to do this right? Wouldn't that be nice? Well, this brings us to what is called the execute around method pattern. Execute around method pattern simply says, I've got a piece of code I want to execute, but around that method, before and after, I want to do some work. I used this pattern actually on a project where we had a service tier where we would create a transaction, set up some details, do some code, and then we would come back and check if there was any problem. If there was a problem, we will come log and roll back, otherwise we'll commit. Well, after about a few weeks into programming, I sat with the programmer to pair program, and we had to write a service level code. And you know what? The first thing he did was he opened up one of the services, highlighted the code in there, Control C, copied over to the new code, removed the middle of it and said, now we are ready to write. Apparently, this is called template-driven development, right? And the point is that there's so much of bulk of copy and paste to duplicated code. So we said, wait. If this is the middle code you want to write, and if there's a pre-op and a post-op you have to do around it, well, that's an execute around method pattern. So we use this pattern for that as well. So how would this code look like if you're going to do this differently? So notice what I'm going to do here. I'm going to first of all, remember we wrote this resource.close method we had a minute ago, and we had no implements auto closable. So this is the code we had a minute ago, and here is a programmer forgetting to write the try and finally block. Well, the very first thing I'm going to do is I'm going to make the close method private. So I made the close method private. The programmer comes along and says, I'm going to call close. It says, no, you cannot call close. And the programmer says, yeah, okay, what gives? And can remove that and move on. Well, that didn't quite help all the way through. Let's try one more thing. We're going to make the constructor private. Now the programmer says, what in the world? How would I even use this object? So now we are forcing the programmer to do one thing in a certain way. So notice what I'm going to do here. I'm going to say public void, well, public static void use, and I'm going to say consumer, and in this case, I'm going to take a resource, and we'll call it as a block one more time. So the structure is very similar, the intent is different, but notice I write a try and finally block all by myself. As an author of a class, I can do this all by myself. I'll remember to do this, right? If resource is very important, as a designer of a class, I can handle this. So what am I going to do here? I'm going to say resource.close, and I call the close on the resource. Well, what in the world is the resource though? Resource equals new resource, and I created a resource object, and then I simply call block.accept and pass the resource to it. So now the beauty is the code can now come in and say resource.use and gets a resource on its hand, and then it can simply say I want to perform this op1 and op2. So this is not one of the ways you can write the code. This forces you to write the code this way, right? So there's no ambiguity. There's no, oops, I forgot to do this, right? So it's all taken care for you. And so as a result, Lambdas are a nice way to implement corporate design policies. You have to do this before you come to this code. When you leave this code, you got to do this. Well, don't burden the programmer with those details. It's a lightweight AOP in a way if you really think about it, right? So you're saying you are going to get this object to use, but before you even get to that point, we have taken care of those things. And then when you leave, we're going to make sure that all these other steps are being done. Some people call this the loan pattern because this is as if you have this particular object on loan, like you go get a rental car from a rental car company. Hopefully before you rented it, they cleaned it up, and then when you return it, they check for damages, more so for me. And then so the point really is that there's a pre-op and a post-op, but right in between, you have the flexibility to do whatever you want to do. So this is called the execute around method pattern. Well, this execute around method pattern actually comes from the Smalltalk days. This was actually written by a book by Ken Beck several decades ago. He wrote this as in a book called Smalltalk Best Practices. And this has been kind of dormant if you really think about it. But now that Lambda expressions are available in a lot of mainstream languages, we can employ some of those good old patterns now and benefit from a very lightweight design compared to what we used to do. So the point really is that Lambda expressions are really changing the way we are going to be writing code moving forward. It makes our code a lot more lightweight. It makes our code expressive. It makes our code easier to understand, easier to maintain. And as a consequence also, some of the design patterns that we are used to and the ones that we are programmed in evolve quite nicely. You saw that I did not use any slides over here. I wrote quite a bit of examples. If you're really interested in the examples or the list of the topics, you're most welcome to download that from my website, and the link is given right here, and you can get it from the downloads page. I sincerely hope you found this useful. Thank you.